Hi, everybody. Welcome back to the Tetrix RoboBench video series. This is Tim from Pittsco Education, and I've got with me a couple of my colleagues. I've got Paul from R&D and Aaron from the Robotics Curriculum Department. And guys, one of the reasons I called you in today is that one of the big questions that we always have from folks is, I see this really cool Tetrix stuff, and I want to get started with it, but I don't know how. And that's a pretty vague question. So generally, we follow up either via email or phone or however we're talking with folks. And we ask how they're going to use it. And that usually breaks down into two main categories. Is they either want to use it in the classroom or want to use it in competition. So I thought what we'd do, if this is all right with you guys, is I'd let you handle the competition side of things. And Aaron, I'll let you champion the classroom side of things. And I'll just pick your brains about some general questions. We know that there's not going to be any one specific perfect answer for everybody. Everybody's got unique circumstances, special situations that are going to require different tactics, but I think we can come up with some general ideas that maybe help folks decide what they need and how they can use it in their different applications. Does that sound like a deal to you guys?
Sure.
Let's go ahead and kind of give me a couple of things. I'll start with Paul, and then Aaron, you can join in. But a couple of things that you think might be common to both type of situations.
Sure. Well, obviously, whether you're building a robot for the classroom or competition, your robot has to move. It has to be able to traverse a field or your classroom or whatever it may be. So typically, we start with the drive base, and most of our classroom bots are built similar to something like this, where we have a two-wheel drive robot and maybe a third pivot using two motors. So that's a great place to start to learn how to control your robot, how to move forward, reverse, and turn. But oftentimes in competition, it takes a little bit more of a complex drive, or it takes a little bit, more power or things like that. So you might have to step up to a four-wheel drive, which is an example over here. What we got over here is a four-wheel drive. And then oftentimes too, depending on the mobility you need in a competition, you may also need a little bit more complex wheel. Typically, a classroom robot may have just a standard wheel, like our Tetrix 4-inch wheels we have here. But oftentimes in competition, you'll see something like a Mechanim wheel, like this over here. But generally, the idea is the same. You usually start with your drive base and go from there.
The chassis that you build is very similar between the two. A lot of times, it's just standard frame,
right,
using the basic Tetrix channel, and it goes together the same way, whether you're building a very simple bot or a very complex bot. Same pieces, same components. Most of those components are in our base sets that we provide at Pittsco. One of the important things that I think is similar between both situations is the way that you organize your kit.
Okay.
Having your kits organized so you know what parts are in it, where your tools are. It just makes things a lot easier, a lot quicker for finding parts. You know what's missing if you drop pieces on the floor. So organization, I think, is a key also in both situations.
Sounds good. So we have to have basic structure. We have to have basic power. We have to have organization. I think those are all good things that are going to be necessary, whether we're using it for competition or the classroom, right?
Yep.
Okay, then let's go ahead to the next thing would probably be are there things that are unique to one or the other? Paul, let's start again with you. What do you think are some things that are unique to a competition type of a need?
Yeah, so one of the things, if you're going to be competing in a competition, obviously you want to first of all, learn what the game challenge is, and oftentimes there are parts that are legal and not legal, and so you want to make sure that you have studied the rule book and you're familiar with the game challenge. And to Aaron's point, oftentimes in the classroom you're building a basic drive chassis, things like that, which is very, very similar to what you're doing in competition. It's just that in competition it may be a step up, if you will, a little bit more complex, a little bit more involved. And so it's great to take inventory of your classroom sets, see what you have, and then look at the competition. What are the tasks that you need to be doing? Am I going to be lifting things, a large distance in the air? If you are, then oftentimes you can look at a linear drive system, where you may have to use a Tetrix rack and pinion or something like that to get the height you need. So it's things like that. There's a lot of parts and pieces that sit in the Tetrix portfolio that aren't included in the classroom sets. that can really, really help you in competition. If you know what the challenge is, you've done your homework, you've done your planning, you can create an inventory of what you may need to give you an advantage in the competition.
So depending on your strategy, you might need specialty parts.
Exactly.
Okay.
Yeah.
Aaron, how about from your perspective? What are some of the things that maybe are unique to classroom use?
I think it starts with the goal of what you're trying to accomplish in the classroom. With competitions, of course, the goal is to win the
Right.
competition or to perform well. But in the classroom, a lot of times our goals are to meet certain learning objectives or certain course standards. And so the way that you go about designing your robotics course in your classroom to meet those standards, whether you're talking about engineering design process or systems thinking, those kind of things, it's important to be able to map what the students are doing, what they're accomplishing as they're building these robots, back to those core standards or those learning objectives. And so to me, that's where it really starts in the classroom. And it's a little bit different than competition.
Sure. The goal is a little bit different, but you brought up something I think that maybe we want to hit on it a little bit more is the fact that you're going to have lots of students working along toward the same goal. So you might need more of the basic components maybe than they would in competition, so that you can everybody be working along the same lines, right?
Absolutely. And one of the things that we do provide is class sets for the classroom. A set of 6 of the base sets will serve 24 students. That comes with curriculum a lot of times for the students to work through, the student guides. There's a teacher guide that walks the teacher through it. And so all of those components together, you might have just using the base set, not as many cool parts and components that you might use in a competition set. But it's there for each of the students to have the same experience as they go through, to be able to meet those learning objectives.
Yes, and those fundamentals that you're learning with the classroom set definitely cross over into the competition world.
Good point. Yeah.
You've got to learn the basics before you can move up to something that's more complex, more powerful, and has a lot more moving mechanisms in it. So the classroom sets provide a great learning experience to get you to that.
Good point, and I think we need to emphasize that all the way through this, that they don't necessarily mutually non-associative, or they kind of can complement each other, whether you're starting in the classroom and go to a competition type application, or actually you're starting in the competition and you move that into the classroom.
Certainly. Things
are not mutually exclusive one to the other. Mm-hmm. If you had to ask guys, or if there's any one thing that would be a nice to have, maybe not a have to have for either application, but gosh, it'd be really nice, what would you tell teachers or coaches that would be? Let's start with Aaron this time.
Sure.
Okay. Well, I would say to go along with competitions, there is no greater way to motivate students than through competition. And that's what I think anyways. And so we provide competition curriculum through Pisco Competition in a Box. If you can bring that into your classroom and get students engaged by having them build robots where they can compete against each other, they're going to be highly motivated to meet those learning objectives and to meet your course standards. And so it's not necessary. You don't have to do that. A lot of our curriculum is written as far as like completing a certain challenge. But if you can turn it into a competition, your students are going to be just that much more motivated.
It's the reason why they're learning, right? Everybody wants to win, so that's the reason why they're learning.
Right.
Paul, how about you, from your perspective?
Well, you need a lot of patience to start with. Obviously, when you're designing a robot for a particular game challenge, it takes a lot of planning. You want to plan. You want to thoroughly understand how the scoring works in the competition, because that'll help you to plan your design. And then, one of the things that gets overlooked, I think, is the tools you have. I think, you need a nice place to work, because most of the time in competition, you're doing a little bit of modification, and we encourage that. You can cut this channel, you can drill it, you can make it your own. And so you need a nice place to work and a nice set of tools and, a little bit of luck. And as Aaron mentions, some passion and motivation, and, your team will do well.
Good. I think those are great things, guys. To kind of wrap this all up, if there was any one thing that you'd want to pass along as really good advice for, again, either the teacher or the coach, mentor, getting ready to go to competition or getting ready for a classroom, what would that be if you could sum it up in one general statement?
Well, from a competition perspective, again, sometimes it can be daunting when you first set out to design a robot for a competition. But not be discouraged. Break it down, break the game down into the different components, and design your robot accordingly. Take it step by step. Work out your drive chassis, get that working, and then add, and then go to maybe the next level. Okay, once I've got my drive chassis work, and remember, there's coding involved in this as well. So not only are we dealing with the mechanical part of our robot, we're also got the coding component as well. So start with your drive base, work up to what goes on top of my robot, whether that be a lift mechanism, an arm type mechanism, or what have you, and just take it step by step, so the problem doesn't seem to be so large. Break it down into nice chunks, and you'll do well.
True. Aaron?
I would say for the classroom, don't be afraid to let the students be the experts. I think a lot of times as teachers, we feel like we have to have all the answers. We have to be able to answer any question that might come up from the students. One of the awesome things about robotics is the ability for students to figure it out as they go. That's part of that engineering design process or problem-solving model. And so for sure, you want to be able to be there to facilitate and help and lend a hand when needed. But don't be afraid to say, I don't know, let's figure it out together, and let the students really run with it. I think that's important. That's an important life skill, not just a classroom skill.
Yeah, that old adage of not just give a man a fish, but teach him how to fish, that they can then do things by themselves. I think that's
Great point.
Spot on. That's exactly a good lesson, and they can use that in competition or the classroom. Either one.
Yeah.
Guys, I know that there's no one perfect answer for every situation, and so I think what we would encourage everyone is to don't be afraid to ask. I mean, we've got people that are education consultants that are available via phone, via email. So on the website, or if you're calling in, or you're at a convention or show, you see one of us or competition.
Send us a chat request.
Yeah.
Just go ahead. Don't be afraid to ask and tell us your unique situation, and we'll be able to hopefully give you a little bit better ideas that fit your specific situation. But I think these are some really good general principles. Hopefully they give you a little bit better idea of what it might be that you need to go ahead and get started either in the classroom or competition. So like we always say, have fun, build some robots, come back and see us.